So these examples, we have to approximate the following. For 65009.269 to one decimal place. Okay, now remember we have to apply the definition of significant figures, definition of decimal places, and rounding up and rounding down, so that we'll be able to get the correct answer for this particular example. So now for this, to one decimal place, remember that this occupies the position of the first decimal place. So this is what we're approximating to get the approximated value. And the number after this is 6, which is greater than 5. So we can round up to this to get the approximated value. And rounding up to this will be that we'll add 1 to this, and then we'll get the approximated value as 65009.3. So this is the in one decimal place. So this is actually the approximated value. So this sign signifies that you've approximated it. So this is the answer for that question for one decimal place. Now to one significant figure, remember we said significant figures are important single digits. So like here we have 1, 2, 3, 4, 5, 6, 7, 8 significant figures. Okay, so and 6 occupies the position of the first significant figure. So approximating this to one significant figure, we're going to round up because the next number here is greater. I mean, it's actually 5, and we notice that rounding up is from 5 to 9. Yeah, so rounding up now, we'll add 1 here, be having 70,000.000. Yeah, so when you round up normally, the rest after that becomes 0. So that is it. So this is the answer to this. Okay, now the second one, we just apply the same principle. 2 decimal places, this occupies the position of the second decimal place. Okay, so approximating this to 2 decimal place, we have to look at the one after that to see if we would round up or round down, and noticing that it is less than 5, so we'll round up, meaning we'll add nothing, and that number becomes 0. So the answer will become 24.540. Yeah, so this is in 2 decimal place. Now for 2 significant figures here, 24 actually, these are the 2 significant figures. The 4 occupies the position of the second significant figure, and we have here about 5 significant figures here. So we can actually round up here because 5 here is the number that is agreeable for us to use to round up to get the approximated value here. And if we round up here, we get 25. 25.000. So this is the approximated value. This is the approximated value. Okay, now the next one is in 3 decimal places. So if you notice, we have about how many decimal places here? From 1, 2, 3, 4, 5, 6. So we have about 8 occupying the 6th decimal place here. So we want to round up to the 3rd decimal place, meaning that this is occupying the 3rd decimal place. So rounding up to this, we're having the approximated value of 0.002. Yeah, so this is approximating to 3 decimal places. Notice it's not significant figure. If we are looking at significant figure, we will not include these zeros here as the significant figures. Okay, so going to the 3 significant figures, we have actually 4 significant figures here. We're not including these zeros. So meaning that we just want 3 digits to appear in this decimal fraction here. So this occupies the position of the 3rd significant figure, 5. So and we're looking at the next one and that is 8. So this is greater than 5. We can round up to 5 to get the approximated value as 0.00166. Yeah, so this is the answer. So you notice that to solve this approximation using significant figures and decimal places, you really need to apply the principle of rounding up and rounding down. Remember, when you round up, you add 1 when the number next to the one you want to approximate to is greater than 5 or is 5, and you round down when the number is less than 5 and you add nothing. So that's for rounding down. Okay,